This next section, we're going to set up what's known as the directional actor. Now, the key things about this in the demo is that it constantly moves, and when it hits the walls, it kind of deflects back and kind of runs backwards and forwards. Now, this is kind of going to be broken down into two main parts. The first component is going to be getting it running left and right, and then the second part is going to be altering the scale, the colour, to kind of change how it moves through the environment. There's only one thing we need to do really quick, is we just need to change what enemy we're talking about. So quickly switch out the enemy directional. Switch out the enemy basic for the enemy directional, which I changed in the last video. And yeah, we're gonna just get a very basic enemy moving, just to get started with. So the first thing we're going to do, we're going to go into our enemy direction. I'm going to close the basic one because we've already covered it. And I'm going to create myself a new event. Now this event is going to be a collision based event. And what we're going to do with it is, usually, when you're dealing with collision, you have, you're colliding with different enemies and actors and objects and things like that. But we're going to use a collision group, and we're going to be referring to a tile, which is, the tiles are under a certain collision group, which, as you'll see when I do the drop down, it's the option of tiles. And yeah, the tiles are what make up the level, and we're going to say when the player collides with the tiles, based on which way it's hit, that's then going to change its direction. So if I just drag out an if function, if I come to collision here, I can access these chunks of code. Now these determine which direction you're facing. Currently you can access them independent of the actual collision event, which I wouldn't do, because it'll basically throw an error, because it won't know what it's kind of looking for. Because even though it'll be able to check whether the top of it's hit or the bottom of it's hit, it won't know what it's referencing against. So for example, if you don't know what tiles are or what it's colliding with, then it'll just throw an error. It's just, the only reason I bring it up is because I've seen people do it in the past, like just open up an update event and drag this chunk of code in, and it just causes problems. So the two that we're going to deal with, at least for this actor, is we're going to just do left and right. And what we're going to do is we're going to kind of set up the two potential scenarios, which is if the left side is hit, you're going to make it move right, and when the right side is hit, we're going to make it move left. Now, with what you're doing, you could do all sorts of stuff. You could make it that rather than altering the X speed, you could alter the Y speed and make it jump, for example. But I'm just going to alter the X speed, which should make it move left and right. So if I give that a quick test, yeah, we should have a character that moves left and right. But yeah, in particular for jumping over objects, setting the Y speed to, I don't know, like -20 when it bumps into two sides of an object can kind of stop your actors from getting stuck on surfaces. For example, if you jump up a wall and the enemy just gets stuck against the wall. So you'll probably have noticed that nothing is happening, and that's obviously rubbish. The reason that's happening is because we need that initial value. At the moment, it looks like it's colliding with the wall, but it isn't. It's just, you might be able to see there's like a slither of a distance where it's not touching the wall. And because of that, neither of these speeds can be kind of given. Like, it can't use those numbers to start, deflecting off the wall. We need an initial value to kind of get the dog moving. So we're gonna, when it's created, I'm gonna set a random value. Now the reason I'm gonna use a random value is because I want it to not always go the same way. I might want it to deflect off the left wall first, or hit the right wall and then bounce around, and that will make subtle changes to how it moves through the environment. And how it kind of behaves, so you don't have them all just running in the same manner. And it'll only do it for the first time. I think in the actual demo that I've got set up, it randomly changes speed, but we'll see how this pans out. Okay, so you can see from this, it kind of jumps around and kind of goes down the level. And what we're going to do is we're going to make some quick tweaks to how it behaves. So we're going to change its animation based on which way it's facing, and we're going to change its sorry, not change its animation. We're going to change its scale to kind of determine which way it's facing. So I'm going to, under the collision-based event, I'm going to grab a scale, a grow feature. And as we did with the basic character, based on which way it's facing, I'm going to change which way it scales. Whoops. And that way, if the character bumps into the wall, it'll change the way it faces. Yeah, so that's set up. The next thing that I'm going to kind of talk about as part of this is getting the kind of different things to kind of change as part of the actor. So changing the scale and changing its speed to make it go down different routes and behave in different ways. So for example, having, as we did with the bulldog, if it's moving at a very slow speed, it'll what's the word? If it's moving at a slower speed, it'll fall kind of down more platforms. So if you quickly watch, so you can see these. Are now running backwards and forwards. Yeah. Now the only issue with that, as you can see at the bottom of the level, is that they just keep going and keep going and keep going until, because the exit to the level, in mine, is too narrow for if you're not at a low speed. If you're going at a high speed, you'll pass straight over it. So the thing that I'm going to want to implement now is I'm going to have it randomly change the speed. So what I want is the faster characters to be smaller and the bigger characters to be slower, so that way the bigger characters can fall down the hole and the slower characters can kind of essentially they're small enough to fall, but they can be faster if they want. That might be kind of hard to explain, but you'll just see in this bit here. I'll be able to explain it. So I've created previously an attribute called dog attribute. Now this is going to change how this. We're going to essentially set this to a value, and it's going to change something about our character. So I'm going to set this to a random number between 50 and 100 to kind of match the scale of the dog. Because at the moment it is pretty much like the if you look at the dog in the scene, if we make it any bigger, we're going to be changing the scale of the dog with this number. If we make it any bigger, it's not going to fit down the corridors. And if we make it too small, we're not going to be able to see it. So the range of 50 to 100 works quite well. And yeah, what I'm going to do is I'm going to use this number to kind of determine how fast this is going to move. So for getting it to move right, I can literally just connect dog attribute into place. Now to get it to move left, I can use this little kind of negate chunk of code, which will essentially set it to the opposite of what it was before. So it'll be minus 75 rather than just regular 75. Now what you're going to see here is going to be moving very, very fast. Considering that before our speed was 20, we might be seeing our actors moving up to 100 speed. So what we would need to do as part of this would be to do something like divide these values by a certain amount. So for example, you could divide them by 5 or terrifying. Yeah, so you would divide them by something maybe like 25 or something like that to give you a. Let's do it by 5. That should be down to a value that's kind of usable. And then once we've done this, we're going to then change the scale of the dog to kind of reflect how big the actor is or how small the actor is. Cool. So you can see these are a lot more kind of manageable speeds. Now you can see that that dog is a little bit slower than the previous one, and you can see this one's catching up with it quite quickly. Yeah. Now you can see that we've still got the problem that this dog is still not falling down. So we want to, for the faster dogs, we want to alter their scale to kind of counteract the fact that they're moving faster. Oh, that one doesn't seem to. There we go. So what we're going to do is, rather than having 100% and 100%, once again, we're going to use these values. So dog attribute, dog attribute. We're going to connect those into place, and those will change the scale of the dog to essentially kind of show how, what percentage size or what value the number is that we're working with. I'm trying to think of a way to explain it. So if the dog is moving faster, it'll be at full size. So the smaller the dog, the slower it's going to move. Oh, that dog has actually managed to stop fully. So you can see this little one here is moving really, really slowly. And yeah, so what we're gonna, let's just quickly see if this guy goes down. So what we want to do is, as you can see, the faster characters are still managing to bridge that gap. Now we could, just make that gap wider, but what I want to do instead is essentially take the value dog attribute and deduct it off of 100, which is the value, the kind of 100%. And what that will give us is that you'll have little tiny dogs which will essentially move very, very fast, and the other dogs will kind of move at a lower speed. So if I let me just disconnect these. Now let me just figure this bit out, because this is where it gets a little bit confusing. Negative 100 minus. It might be the other way around. No. Let's just give that a quick check, see what happens. I mean, what's quite nice with these things is that you can kind of just experiment with them, and using different attributes you can create all sorts of kind of bizarre setups for your characters. So we'll quickly test this. You got that little super tiny, fast moving dog. Wow, that is a really, really, really small dog. So maybe we could do to increase that value by a little bit, because we have literally dogs that are near invisible. So let's let me think. Let's try making this. Let me just think off the top of my head. Let's do 150 for these values. Now the reason we would do that is because if we go to our random dog attribute here, 50 is going to be 100% of your, the scale. We're essentially taking the scale of the dog, which is 100% when it begins, and we're deducting an amount off it. At the moment, we have it that potentially the dog could be invisible, because we could deduct 100% off of it. If we add 50 onto that value, the dog attribute would either at 50, like if we deducted 50 off 150, that would give us 100%. So that's the minimum, value, and then the maximum value, it could take its scale down to 50% by taking 100 off. Because what we're doing is we're taking the initial value, which is 150, and we're deducting, the dog attribute's value off of it. So if we quickly test this now, this should have the dogs at a more sensible size. Apologies if this is kind of like meandered slightly, and obviously been a bit longer than the last video. But yeah, this is just kind of like a little extra section if you're wanting to do it, which just kind of allows you to do stuff like, so you can see like from the different behaviours, you've got a super fast dog, which is like now scampering along, and then you got your slower dogs, which move at a lower pace. So there's like this little one scampering down from the top, and now you can see that all of the enemies are actually making it down that hole at the bottom. So just kind of summarise how that's working. You can see the code at the side here whilst it's happening. The way that this works is when the object's created, when the dog is essentially created, we're grabbing a random number between 50 and 150. Sorry, a random number between 50 and 100. this value, what we do with it is we have a collision-based event, which is checking whether the actor's collided with tiles, and based on which side of the dog is hit, we then alter its scale using the attribute as a value that we deduct from the beginning scale of the dog, which would be negative 150. Sorry, 150. And by kind of reducing this number, we can get different scales. Now, this is kind of unique to my case that I've got here, because I want my characters that are bigger to move slower. In your project, you might want your characters to move faster. If there's, you know, if they're bigger, which kind of makes more sense than the other way around. So yeah, you can have an experiment, you know, with these attributes yourself. And yeah, we've pretty much covered this. The only thing that might be not quite nice to add as well is a visual indicator, which we already got the scale, but it might be good as well to change its colour, to kind of give the player a visual indicator of, you know, what enemy they've got coming down and what route that it might take based on its size and its speed. So if we quickly test this, you should see like a rainbow path of dogs coming down from the top. As you can see, they're all, even though they're all kind of similar-ish colour, there's slight kind of tints and changes in how they look. So you can see we've got kind of like a kind of more of a cyan with this character and more of a leafy green with this one. If we wanted to increase that and make it more extreme, to kind of make it a little bit easier to tell the difference between the character types, what you would do is you'd essentially just multiply this number by a larger value. So, you know, you'd maybe multiply it by 5, which would mean that it would cover more of the colour wheel. So the, you know, the differences in colours between the different scales would be a bit more extreme. But other than that, this pretty much covers everything for the directional enemy. Yeah, so in the final section, what I'm going to be covering is an enemy that's going to kind of move towards you, and then in turn, if it gets within a certain range, change colour, and begin to kind of bark at you. So you can see now, you've got your bigger dogs, which are kind of purple. And then as you get, okay, what I'm just going to very quickly fix, which you all might have noticed, is this initial value isn't working as well as we would have hoped. Now, what we could do to fix this is, let me think, rather than using this X speed value, we're having a couple of situations where if the speed is 0, it's just not moving. So what we could do instead is, we've got this range between like 50 and 100. What we could say is, when created, if dog attribute is greater than 75, set X speed to 20, or you know, you could even do, let me see, you know, you could essentially just take this chunk of code here, and plonk that into place. And that'll alter the scale at the beginning of the game, and it will also set its speed to move in a certain direction. And then what you could do is say otherwise, you know, do the other solution. And that way, rather than it kind of first time it bumps into a wall scaling, what it will do is the moment it's created, it will choose its scale and it will choose its direction to move in based on whether it's greater than or less than 75. Yeah, which should give you pretty much a 50-50 split on, you know, which way the enemy will initially move, which hopefully should look better than it did before. There we go. So that kind of pretty much wraps up setting up what is quite a nice looking enemy. As I said, the next bit's going to be getting the kind of giant floating dog head, which is going to move directly towards the character and then change its behaviour as it moves into range. So yeah, we'll cover that next.